Hello viewers, 4DIYers here with another video for everyone. In this particular video here, I'll be showing you the easiest way to install off-road or auxiliary lights on your vehicle. This will be based on a kit from Auxbeam. The link to these lights and mount will be included in the video description. This kit includes the lights, along with the wiring, which will be slightly modified for a cleaner install in this vehicle. Beyond the lights, Auxbeam has also sent me a mount, which requires minimal modifications to install the lights. This mount fastens behind the license plate and can be fitted to any vehicle. For this I'm using the 2001 Toyota Tacoma as an example, so if you do have the same truck, there will be some tips along the way for running the wiring and switch install. Auxbeam has also provided me with a discount code for any orders. It's 10% off a purchase, and the code is 4DIYERMR10. For our lights, I'll be using Auxbeam's 2-piece 5-inch square LEDs. These are 55 watt each, have a 6000K color temperature, are spotlights, IP68 rating, and are 11,000 lumens. I'll have a review for these in the upcoming weeks. These lights also include all the wiring required to hook them up. It's long enough where you have a wide range of areas to mount the lights. The wiring also includes a relay, protective casing, and even an interior switch. I will be trimming up the wiring to fit the truck so it's a cleaner install, and the supplied switch will be swapped out for one too. As for the mount, this gets fastened directly behind the license plate. It's a universal bracket which can be installed on most vehicles. It's all aluminum, so there's no need to worry about any rusting, has a black satin finish coating, is very rigid and extremely light. First is removing the license plate to determine where exactly the mount will be located. The mount uses the factory license plate bolt hole locations, so it makes it an extremely easy install. However, due to the shape of the bumper, there is a small space between the rear of the lights and bumper, but over rough terrain or even at highway winds, this may cause some contact. Therefore, the license plate mount will be raised up to the next set of holes. I'll show you the install for the mount in more detail further on in the video. As mentioned earlier, the wiring does come with a relay. Trying to determine where the best area is to install the relay without extending the power wire and keeping it protected from any road debris. Between the battery and inner fender seems like a good area. First is removing the battery. Disconnect the negative terminal first. Then move on to the positive terminal. And finally, the battery clamp. Specific for the Tacoma, the battery terminals use a 10mm and the battery clamp uses a 12mm. Determining roughly where the relay will be mounted, it has a tang on the top to be mounted on a fastener. There are some factory holes, but nothing which I found in a good location. Instead, I'll be using a nut cert. This is very similar to a rivet, and unfortunately you'll need a special tool for the install. The tool expands in the hole like a rivet, but has a fixed threaded insert for mounting. First is drilling the hole the appropriate size. I would recommend using a step drill as it does leave a clean hole in sheet metal. A caliper can be used to determine which size is required on the step drill for the nut cert. Drilling the hole. Considering the edge of the hole is bare metal and will rust, I would recommend touching up the edges with some paint as protection. Then install the nut cert using the specialty tool. Another option can be using existing threaded holes, or even using an expanding trim clip, which is available in a variety of styles. After that is installing the relay. The relay is required to have a positive and negative wire hooked up. The positive wire can be done after. This has the red insulation. The black is the ground wire, and this can be connected to the factory ground location. The I-clamp terminals going to a bolt on the main body is a common ground. This can be used for the relay. Simply remove the bolt, add the ground eye from the relay, and reinstall the bolt, then tighten. The wiring already had a protective casing, so there's no need to add your own. If you are adding your own, I would highly recommend using split loop casing instead. Looking under the dashboard and along the firewall on the driver's side, I managed to find an unused grommet to run the wiring. Another option is drilling your own hole, then adding your own grommet, or trying to run the wiring through a factory wiring grommet. I was able to remove the grommet from the engine side. The grommet doesn't have a hole. You can purchase versions which are intended for wiring, but instead I'll be making my own hole. Here I have a specialty punch for making holes. These are typically used for bolt holes and gaskets. I'm making the hole off to one side so it doesn't distort the grommet too much. Using a hard base, for this I'm using steel. This will provide a clean cut. Then using a razor knife, cut a slit in the grommet. The wiring connector can't fit through this hole, however with the slot, it can be slid over the casing. For running the wires, they are ran in a safe area away from any moving parts or hot components. I wrap tape on the connector to keep out any dirt or grease. It's ran behind the fuse box along the inner fender, then routed around the brake lines and down to the hole in the firewall. After that is putting the rubber grommet on the wire. Then finally it's installed back into the firewall. Make sure it's seated correctly. The hole is a little tighter for the wire. I made it a smaller size so it's a tight fit. Going from the inside of the vehicle, you can help pull the wire through. Here's another view under the dash so you can see where the wiring is ran through the firewall. It comes through the spot just above the white connector. Finding a spot to mount the switch. The lower knee panel seems like a good spot. Typically I like to pick an area where more switches can be mounted. Auxbeam does provide a stick-on switch which can be mounted anywhere, so if you're worried about damaging your interior or wanting an easy switch back to stock, then this is an excellent route. For a switch, I'll be using a round rocker style switch that can be easily installed. All I need to do is drill a round hole and open it up a little more for the correct size. Make sure the switch doesn't have any interference with objects in behind, even when it's installed. A spade bit, which is normally used on wood, can be used in plastic too. To open up the hole slightly, I used a stone on a drill. A cone-shaped version keeps the hole round while opening up to a larger size. Install the switch. The switch has clips on the side where it just snaps into place. No fasteners are needed here for this type of switch. Here you can see what the switch looks like once installed, both on the front and back side. The factory holes for the license plate is stripped, which won't provide a strong base, and the plastic had some flex, which may make the lights vibrate. With any plastic bumpers, I would highly recommend a backer plate with threaded holes for rigidity. I picked up some 1/2 inch by 3/4 inch aluminum bar. It'll be a perfect fit in behind the thinner lower plastic lip. The bar will be cut to the same width as the mount. It'll have 4 threaded holes, 2 for the outer holes and another 2 for the mounts on the license plate. All will help keep the assembly firmly in place. A marker is used to rough out the dimension areas. It's easier to see this with scriber lines. Then is marking out the exact dimensions on all 4 sides to ensure it's square. Keeping this project on a simpler note, and being aluminum, this can be easily cut using a hacksaw. The cut edges are then cleaned up using a file. Mark out the holes, make a center line, and all the holes will be measured off here to ensure it's all centered. If there is a slight difference in the size between the aluminum piece and the light mount, they can be still centered up with each other. Again, rough locations of the holes are done with a marker. And finally is using a scriber. I didn't make the holes on center but slightly off to one side, just in case there's any interference with the bumper. I can flip the bar over if there's any interference in the back side, and this will provide a slightly different mounting position. I also reference everything with the truck, making sure it's in the proper position. The license plate holes are an exact match with the factory spots on the truck, so I'm not having to drill new holes. I can use the existing location. A center punch is used to keep the drilling locations accurate. I will be doing the drilling and threading on the drill press to keep everything square. The holes are first center drilled, a pilot hole is made, and then a final size is done that is required for the tap. If you're wondering how to drill and thread on the drill press, check out my metalworking channel for that tutorial. An alternative to threading material is using a thinner piece, such as a 1/4 inch thick, with nut certs, or simply using a bolt through the bumper with a nut on the back side. Once done, here you can see the final setup for the rear mounting piece. The aluminum was cleaned up with an abrasive pad, and it can be painted if you wish. I used metric fasteners to match the truck, as it uses metric as well, and my fastener of choice is a button socket head for a smooth look. The original holes for license plates gets opened up to accommodate the new fasteners. The backer piece gets installed on the outside. This will help marking out any holes instead of measuring them. Then the holes are marked out using a pencil. First is making the small pilot holes to keep everything fairly accurate. The final holes are drilled using a step drill bit again. The bracket then gets installed in place. You'll see in a moment where I did change the mounting height of the bracket. To run the wires, I found it's easiest to remove the grill, so I do have more access in behind the bumper and headlights. This will allow me to keep everything tidy, and I can fasten the wires in place using cable ties. The kit has 2 separate wires for each light, so they can be mounted in a variety of areas. Mine are close together, so it's best to keep the wiring together as well. Cable ties are used every foot to keep this clean, and to prevent the wiring from catching up on anything. It runs in from behind the headlight opening, along the radiator support, and then from behind the license plate area through the bumper opening. Using a razor knife, the outside casing can be carefully cut. The wiring can be used in a wide range of vehicles, and the lights can be mounted in the front or rear depending on your application. Once that casing has been pulled back, you can then cut the wiring to length. I'm trying not to cut up the wiring too much, as this can be saved for a future project. It's always good to be able to reuse new access wiring. After that, the wiring is then stripped for crimp connectors. Use the appropriate size wire strippers when doing so. The wiring for the lights are left in their almost full length. I just cut off the pre-stripped conductor as these strands were tangled up, and then stripped them to my liking. For connectors, typically I would recommend using a waterproof connector, and I do have a video for that as well. But I'm keeping this as simple as possible, so this will be an alternative method, which is still correct, but you're not required to have a specialty crimper tool or purchase any specialty connectors. For connections, I'll be using a male and female spade connectors. The male version will be installed on the lights. These terminals have a heat shrink connection, which will provide more protection and looks cleaner. Twist the wire strands together, install the connection, and crimp. Make sure you are using the insulated specific crimper. Always give them a pull test to ensure the connection is tight, and finally finish up with a heat gun to shrink the terminal's insulation. On the wiring side, these will have the female spade terminal connection. The female side will have the terminal shielded, with this being the power side. If the lights are unplugged, they're always protected. From what I've found, the female terminals have shrink tube added to the solid insulation. Instead of buying my own, I just made my own version. I already had terminals and heat shrink. Install the heat shrink first. Make sure the wire strands are twisted. Then install the terminal and crimp the connection. When done crimping, always give it a pull test and push the heat shrink in place over top of the rigid terminal insulation. Using a heat gun, contract the heat shrink. Here are the connections when done. They will provide some weather protection. When the lights are hooked up, there's really no need to disconnect them unless they're being replaced from damage or wear out. As an added step, the spade terminal connection will get an additional layer of heat shrink. I already tested the heat shrink rate. It closes up just enough where it's a tight connection around the crimp terminal portions. This can be easily removed using a razor knife in the future. A quick test is done to ensure everything is working correctly, so the battery goes back into place. The fuse can be removed while working on the system as a safety precaution if you wish. As you can see, the bracket was installed on the second set of holes to increase the height, but due to the height increase, the bracket does have some movement, which will make the lights move. Therefore, an extra hole will need to be drilled in the steel portion of the bumper to improve rigidity. A piece of tape is applied to the bracket so I'm able to mark out the additional hole. A hole will be drilled in the center of the bracket for a new fastener, and then this will be opened up for the correct size after. The bracket is then reinstalled back onto the truck. I can transfer the location of the hole over on the bumper. I would have drilled the bumper with the bracket in place, but due to the bar being lower, I'm unable to get straight access into its location. The bracket was then removed, and then I drilled the hole. A step drill can be used here as well, as it is thinner metal. To prevent the paint from chipping around the hole, I applied tape. And then I finished up with the final size. The bare steel was touched up with paint to provide protection against rust. This is the same nutsert as I used previously. They're available in a variety of sizes along with metric and imperial. An alternative method to this would be using a nut on the back side if you don't have the correct tool for installing nutserts. As for the switch, I kept the supplied connector, but cut off the switch. This is a 3-wire switch. I was able to determine which wires are required for the switch by shorting out the terminals using a short piece of wire. The third wire is used to illuminate the light within the switch. The wire was cut to length using side cutters, then the outer casing was stripped using a knife. Finally, crimp connections are added with spade terminals to match the rear of the switch, and the third wire is capped off with heat shrink. The switch is already in place, the plug is connected, and then the trim can be put back into place. I left the wire long enough in the future, if the panel is removed, me or someone else has enough room to access that plug to disconnect it. Finishing up on the inside, all fasteners are put back into place. As for the wiring on the switch, it was ran along the factory wiring and snapped into place on the factory wiring retainers. The bracket is installed back onto the bumper. If you haven't seen my review on this bracket, be sure to check it out. I have already inserted the supplied bolts into the lights. With the rubber mounting pads, they're installed onto the outer holes of the light mount bracket. Flat and lock washers are supplied with the lights. As an added step, I also applied some medium grade thread locker as well. The lights are then plugged into place on the main harness. They're tested before everything is finalized. Larger heat shrink was used to seal up those spade terminals. This is regular heat shrink and doesn't have an adhesive that would bond to the terminal, and that would cause problems if the terminal need to be disconnected in the future. In the case of light replacement, the heat shrink can be cut off just as mentioned earlier using a razor knife, the terminals can be unplugged, the light can be replaced, and more heat shrink can be added. The wiring is pushed back behind the bracket and tied off using cable ties. The rest of the wiring is cleaned up using cable ties and fastened to the radiator support. The grille is reinstalled back into place along with the marker lights. The plate is put back into place then. A demonstration showing the supplied switch from Auxbeam. Isopropanol alcohol would be recommended for cleaning the surface before installation. Remove the protective film on the adhesive pad, then firmly push the switch into place on the desired location. When the lights are off, the light on the switch will remain red. If the lights are on, it'll change to green. For removal, you can simply pull this off, returning back to stock. As you can see, the switch I installed is in an accessible spot for the driver. And here's the final look. A mildly upgraded look to the front of your vehicle with minimal work while keeping everything fairly stock, and it's done right so there's no need to worry about any issues down the road. This is by far the simplest way to add off-road lights or auxiliary lights to your vehicle. A similar process can also be used for a rooftop light, other forward-facing lights, or even rear-facing lights. New videos are released every week on my channel. Be sure to hit that thumbs up button. It's a huge help to me, and leave a comment below if you found this tutorial helpful. If you're not a subscriber, be sure to also hit that subscribe button. Thank you for watching.